Okay, welcome everybody to our second part of the session for scaling networks. We're going to be doing the skills integration challenge for OSPF today. So let's go ahead. So get yourselves ready. We're going to be doing activity 10.3.1.2. So let's go ahead and read the scenario. So we basically have a network topology. We do have three routers, router A to the left, router B at the top, and router C at the right hand side. Router C does have a connection to the internet, which is probably going to be configured as a default route, I believe. We also have a web server somewhere located on the internet. Okay, so our main purpose is to configure OSPF. The IP addressing has already been configured, as it said here in the instructions. So we will be configuring OSPF v2 routing. So we will remember about the passive interface commands, how to propagate the default route, and then we're going to modify the configuration to adjust the OSPF timers. And finally, we're going to verify the configurations and test connectivity between end devices. So the requirements are: use the following requirements to configure OSPF version 2 on router A and router B. So in the first part of the activity, we're just required to make an OSPF adjacency between router A and router B. So we're going to be configuring OSPF version 2. The process ID will be 1, and the network address that will be advertised will be the network address of each respective router. After that, we're going to change the OSPF priority from the default value to 150 on router A and from the default value to 100 on router B. And we're going to play with the hello and dead intervals. After that, we're going to configure router C with the same OSPF version 2 process ID 1. We're going to advertise the network addresses of router 3. We're going to set the passive interface default and only allow the updates on the active LAN. After that, we're going to set the router to distribute a default route. We're then going to configure the directly attached default route to the internet, configure the priority, set the hello interval and dead interval in router C as well, and then we're going to observe who is going to be the designated router or backup designated router and so on. So let's go ahead and get started. I'm going to start with router A, CLI, and let's do just that. So you can participate with me and type the commands in the chat if you want. Feel free to do that. So in order for me to configure router A with OSPF process ID 1, what do I need to do? So first thing is we need to remember that when we configure dynamic routing on a router, we need to be in global configuration mode. So I have to do enable, you're going to privilege exec, configure T, and go into global configuration mode. Now from global configuration mode, we are then able to create OSPF routing. So how do we do that? Does anybody remember the command? Let's go. Anyone? Yeah. So router OSPF. Now we do have to specify the process ID, which is 1. So router OSPF 1. And we're pretty much done. Now, it doesn't actually tell us to configure the router ID. So we just basically don't need to worry about that at the moment. Pretty cool. So we are not going to configure the router ID because it doesn't tell us to do it. So process ID 1, network address for each interface. Now let's check the table. We only have one interface on router A, which is this 192.168.1.1 and the subnet mask, which is /24. So how do I advertise this network in my OSPF process? It's with the network command. So let's go ahead, network, and then I can specify it in 2 ways. One way, I can specify the IP address of the interface, and then I can use the all zeros wildcard mask, or I can just specify the network if I want, and the wildcard mask, which is 255. Now, if you want to make sure your wildcard mask is correct, if you add your wildcard mask with the subnet, the result should be the all 255s. If it is, you calculated the wildcard mask correctly. In this case, we are done. Now, is there anything else I need to specify it as well in my OSPF network statement? So if I just type this, it's not enough. Yes, so we do have to specify the area. And because it's single area OSPF only, we're going to go with area 0. So network, the area that is going to be advertised. And that's all we need to advertise this specific network into our router OSPF process 1. So first step is done for router A. Let's go ahead and do the next step. So the priority on router A should be 150. Now, priorities are configured on an interface by interface basis. So you have to remember this. So if I use the question mark in my router OSPF process, I have no option here to set up the priority. So what I need to do is I need to go to the interface and change the priority. So the interface here is gig 00, which is the one that I'm going to be forming the adjacencies. So I need to change the priority of interface gig 00. Let's do that. Int, exit, interface gig 00, and type the command to change the priority. Does anybody remember from the lecture? Anyone wants to give it a go? So to change the priority is IP OSPF priority, and then followed by the priority number, priority value, which is from 0 to 255. Remember that 0 will remove it from the election. 1 is the default, and 255 is the highest possible value we can have for the priority. Now, in case the priority values are the same, the router with the highest router ID will be elected. So we have to specify 150 for router A. And then we have to change the hello interval and dead interval on router A as well. Now the hello and dead interval, they are configured within an interface by interface as well. So IP, what else? OSPF as well. And then the options we have: hello interval, dead interval, cost, authentication, network type, and priority. Now, in this specific case, we want to specify the hello interval, which is going to be set to 5. And the dead interval, which is going to be set to 20. Now, the recommended is, if you're going to change the dead and hello interval, recommended is that the dead interval should be at least 4 times more than the hello interval. Okay, that's why this is 20 and the other one is 5. All right, use the following requirements to configure C. Oh yeah, so with this, we basically finished with router A. Now we are good to move on to router B. So with that, we wanted to save the config. Do the while we'll do the job. All right. Now let's move on to router B and do pretty much exactly the same thing we did in router A. I'm going to go to CLI, enable conf p router OSPF1, and then we don't need to specify the router ID because it's not given. Now let's advertise the networks in router B. So come on guys, give me the command. Anyone? Network and for router B, we want to advertise the 168.1.2. So 192.168.1.2. And then we're going to go with the wildcard mask 000 block 255. Okay. Once again, don't forget, we need to specify the area. And done. Okay. Cool. So what's our next step? So next step is changing the priority on router B. So that's done in an interface by interface. So gig 00, IP, OSPF, priority 100. Done. So we have now modified the OSPF priority on router B as well. We also have to modify the hello and dead interval. IP OSPF hello interval 5. IP OSPF dead interval 20. Done. Okay.
Rob,
So, yep.
would the mask for point 1, point 2 be all 0?
What was that, Surzak? I didn't get it.
The network 192.168.1.2, would the mask be all 0? 0.0.0.0.
It could be, but it doesn't have to be. There are two ways to do it. So one way is you can put the network as it is, or you can specify the IP of the interface.
Yep.
So there are two ways you can do it. Both ways will work. All right. Especially because if you specify the wildcard mask here,
Yep.
Surzak, you are already specifying the network. So you see the way that I put it here? You see the way I put here? Now, if I show my running configuration, you'll see something. If I go to the OSPF pod, check this out. I didn't put it this way, but because of the wildcard mask, the router understands that that's a network. Okay?
Yep.
So it will convert it to a network statement. Okay? So that's why you can do it in two ways. You can put the network straight away, or you can put the IP of the interface straight away, and then the router will convert it into the network statement. Okay, so you can do it in both ways.
Robert?
Yep.
When we put the interface IP address, so we put the address and then 4 zeros afterwards, or we don't have to put anything?
If we put the all 4 zeros, that will match the interface. So if you just want to put the interface, you can go with the all zeros instead. Okay.
All zeros will advertise all networks that are connected to
the interface that you put the IP address.
So we can do it like that. We can put 4 zeros, and we can also put the IP of the interface.
Yes.
The place to do it.
Yes.
Okay. Thank you.
No worries. Okay, so we basically done with router B. We already set the hello and dead intervals on router B. So we're good to go and move on to router C. Now, before we move on to router C, I'll take advantage of the fact that I'm here in the show run. And if I check the interface gigabit 00, check it out. The OSPF hello, the OSPF dead, the OSPF priority that we just configured. Okay, they are all going to be under the interface configuration. Okay, let's move on. Third router. Pretty much the same thing. We initiate the OSPF process. Enable conf t router OSPF 1. Oops. And then we specify the networks. What are the networks? So it's actually telling us the network address of the LAN, which is this. Now, in this case, I'm going to specify the one that I just told you guys with the interface instead of the network. So let's have a look. Network. So instead of using the network in the wildcard mask, I'm going to give you the example I said before. So 192.168.1.3, which is the IP of the interface. And then instead of putting the wildcard mask, because this is already the IP of the interface, I'll just go with the all zeros. Okay? I'm just basically saying the network that is contained in this interface. All right? And it's area 0 as well. And let's see what happens next. So we typed it in. So let's go back a little to show run. Let's see what happens. All right, let's go to OSPF. check it out, it actually there. But now it didn't convert it to the network, but still the network connected to this interface is advertised. Okay, even though it's not matching, it's still advertised anyways. Okay. All right, so let's have a look at what else we have to do with router C. With router C, we also have to specify the interface. So set all the interfaces by default to passive, but allow the updates on the active. Now, any plans on how we can do that? Any plans how we could do this? So it's with the passive interface default. So I'm gonna go router OSPF1 passive interface default. Now remember that setting the passive interface default will make all the interfaces passive by default. Okay. Now, because we did this, we need to specify which one we want to form the adjacency. So it tells us that we should allow the updates on the active LAN. So basically this LAN interface of router C needs to be specified as not passive. So I'll check the table to see which interface is that. It's the gig 00. How do I remove the passive feature on this interface? Does anybody remember that? Anyone? Yes, so let's go ahead. No passive. Interface. And then we specify the interface, which is gig 00. And that's all we need. Okay. See what else? Set the router to distribute the default routes. Now, before we distribute the default route, let's see if the default route exists. I'm going to show the routing table. Do we have a default route? We actually don't. It's not even here in the table. All right, so we also have to create it as well. Okay? Not only advertise it, but create it. All right, let's create it first. And how do we create this default route? Anybody remember? How do we create a default route? So it's with the command IP route, correct? So I'm gonna go to router C, IP route. So I'm basically creating a static route. So if you don't know where to forward the traffic, okay, that's what the all 0 means. If you don't have any match, okay, in the routing table, I'll give you a way out. Okay? And the way out here is the way to the internet. So we could specify the IP address of the internet connection or the exit interface. Okay, so I'm not sure how this packet trace is configured to grade, but let's do it based on the interface. Let's see if that's what it tells us. Configure directly attach default route to the internet, so it doesn't specify. So we're going to try doing it with the interface exit. The exit to the internet is the S000. We're going to try to specify just that. So if you don't know what to do with the traffic, send it out of your serial interface. Let's see if that's what the activity is expecting us to do, or if it's actually expecting the IP. So yeah, so it looks like it accepted the exit interface. We don't need to do anything else. Okay. We get a warning saying that the default route without gateway, if not a point-to-point interface, may impact performance. Just a message for us to consider. All right, so now that we create, yep.
can we guess it from that, because the net rate is select 30. So if as it 255, the next one have to be 226, right?
226. Which one are you talking about, Surza? Here? In the text?
Because instead of we use the our interface, we can use the internet
Yes, yes. you
address,
could-
right?
Yes, yes. Instead of the interface, we could use the next hop. Yeah,
Yep.
the next hop IP. Okay. So now that we created it, how can we advertise it using OSPF? So first of all, we have to be in OSPF configuration. OSPF 1. And we have to type the command that we discussed before. Default information originate. Originate. Okay. So that will do the job. It's going to advertise the default route. So what else we have to do? Configure a directly attached default route to the internet. The OSPF priority needs to be set to 50 on the LAN. We have to go to the LAN interface, which is gig 00. And we have to change the priority. The OSPF priority. And the priority in this case will be 50. All right. And the hello and that interval also have to be changed. So hello interval. Oops, IP OSPF. Hello interval 5. And the IP OSPF dead interval 20. Okay. What else we have to do? Set the hello to 5, set the dead to 20. And now we do have an adjacency being formed. All right. Now issue the clear IP OSPF process on C if the default route does not propagate. Verify configuration and test the connectivity. So let's go ahead and check what's happening. So first of all, let's see if we have an adjacency. So from router C, I'm gonna do show IP OSPF neighbors and check it out. We do have both our neighbors. So they are neighbors. Okay. And who's the designated router? Who's the designated router, guys? Designated router is the one with IP address, router ID 11, which is router A. Why? Why, Nipes? Why is it the designated router? Because of the priority value, okay, which is 150. So let's check if the default route has been propagated. So I'm going to go route A. How do I check if the default route is in the routing table? By verifying the routing table. A show IP route here will do the job. And check it out. OE2. Now, does anyone know why is this asterisks? There's an asterisk here because it's a default propagated default route. And does anyone remember why is this OE2? Why is it E2? Because it's external. It's not coming from within an area. It's actually coming from outside. Okay. And does anyone know what's the term that when we have a router which is connected to OSPF but also connected to outside, and that will send the LSA type 5s? Does anyone remember the term? ASBR, Autonomous System Border Router. Yeah, cool. Okay, so that's an OE2 route. All right. Questions? Any questions? So apparently we're still missing 5 points, even though everything looks to be working. Now, if If I go from my router A, if I try to ping the server, let's see if it works. Does it actually work? It does. Okay. So OSPF wise, everything's working. All the routes are being shared. So apparently there are no issues here. Okay. So OSPF neighbors should be established and routing table should be complete. Router A should be DR and router B should be the BDR. All the routers should be able to ping the web server. Let's try it from router B. Ping 64, 100, 1, 2. It also works. How about router C? 64, 100, 1, 2. It also does work. So everything's working. So we are learning routes, we are exchanging routes. So apparently we are still missing one thing. Okay. And I believe that is just the way that Packet Tracer does the marking. I'm probably expecting that the network command that we entered in router C was not supposed to be the all zeros in the wildcard mask, was supposed to be the wildcard mask specific. I think that's why we're not getting the 70. But in reality, that's not going to make any change, okay? If you're doing this in a physical equipment, it would be the same, all right? Let's check the results. And that is exactly what I was expecting, okay? So it's just because of the way that someone did the marking in Packet Tracer, it was marking a specific command, okay? So it was not giving any marks for specifying the IP of the interface. As we saw, there's no difference. Everything works the same, just as expected. So there wouldn't be a reason why this has to be like this. It must be like this. It doesn't, okay? Now let's just make a change to make sure we get the 100% score. I'm going to go back to router C. I'm going to remove the network command I typed before. (255) area 0. And we're going to replace this one for the network command instead. Oops. Oopsie. And that's all we had to fix. Now, please note, guys, just as I told you before, it doesn't really matter which one you want to put it in, okay? It's going to work as expected, okay? In this example, we just had to go with a specific one just because of the way that the activity is marking, okay? That doesn't mean it must be just like this. It doesn't, all right? So we just basically achieved the main goal. All routers are able to access the web server. The default route to the internet was successfully propagated from router C to router A and router B, right? So objective accomplished. All right, guys, sorry it took a while. 25 minutes, good timing. All right, was that clear?